All right, this section here, we're going to be basically talking about the cleaning system and trying to understand a little bit what the theory is behind the operation of the cleaning system. So first of all is all Flagship combines have what we refer to as a self-leveling cleaning system. And self-leveling cleaning system means that the whole portion that you have over here will actually oscillate from left to right underneath the combine. And I'll just walk up to the front here and just hit the switch, and you should be able to see it move back and forth. Okay, it'll oscillate over to the left and then oscillate over to the right, or vice versa. Okay, so it's good for approximately 12% slope, somewhere in that area. So when you're working in the field, constantly this thing is moving from side to side depending on which way the cab is the one that determines if the combine is level or not. And then it sends a signal to an electric actuator and makes sure that the cleaning system is level with the body of the combine, so that you can make sure that this grain pan stays flat all the time. So again, we talked about grain pan a little while ago. Grain pan itself, what it's there for is to stratify the grain from the chaff. Okay, the shaking motion, forward and back, tosses the material up. The grain is heavier than the chaff. It'll automatically fall down faster. Clean grain will be on the bottom, chaff will be on top. Then it moves towards the back, hits what we call the pre-sieve. The pre-sieve allows 10% of the kernels to fall through there onto another similar grain pan as this, underneath the pre-sieve. That grain pan brings those clean kernels over and dumps them down onto the front of the bottom sieve, so they get cleaned one more time. I talked a little bit about the adjustments of the pre-sieve. The adjuster is located at the back, so I go and adjust the adjuster over there in order to set the position that I want this. And again, my rule of thumb is just that you never want to close it below 1/8 of an inch or 3 millimeter, and then from there on you never want to open it any bigger than the size of your kernel. So use your kernels as your measuring device. Moving on a little further back, I have the top sieve, and underneath I have my bottom sieve. Now, the angle of the sieves becomes a little critical. So again, if I use an angle finder and I put it onto the frame of the combine, this is the lower frame, I put it on there, and then if I am more than 4 degrees up at the back end of the combine, I need to lower the rear axle. And again, a lot of people says, well, why is that? Well, because if you raise it too high, how the system actually operates, if you look at my arm over here, if I take the whole body of the combine and I raise the back end up, and I'm going to exaggerate with my arm, okay, so now it's quite a bit steeper. The movement of the shaking system, if I'm level, the movement goes rearwards and up, like so. Okay, so the reason it's doing this is so they can toss the material up in the air and at the same time move it towards the rear of the combine. So if I toss it up, that's where the air can actually get underneath. The chaff is lighter than the wheat or any crop that you're doing, so it'll take the debris and it'll blow it out of the combine and allow the kernels to fall back down, go through the sieve and go through the bottom. Now, if I raise the back end of the combine like this, the shaking motion is the same. It goes up like this. But as I'm moving it towards the back of the combine, I'm catching it again, and then it wants to roll forward. Debris, it cannot jump up as high, so the air doesn't have as much chance to get underneath, lift the chaff, and let the kernels fall through. And then you end up with dirty sample in the grain tank, and you end up with loss. So just be conscious not to get too crazy with the back end and jack it up, because most people think if they jack it up, they're going to save more grain. That's not the way it works. Okay, you cannot change the geometry of the profile of the combine. You need to stay within that parameter. Now, difference in sieves. There's different sieves available for the combine, and in the operator's manual there's a page in there that tells you how to measure the sieve and how to identify which sieve that you have. Okay, so basically a way to measure it is it's measured from the wire that's holding the louver to the next wire. So there's 1 1/8 or 1 5/8. 1 1/8 is mostly used for small grain. 1 5/8 is used for other grain. Okay, so this sieve that you have here on top happens to be the small grain slat. The one that I have over here, it's 1 1/8 from here to the end, to the other wire. That happens to be a closed slat. The one that you have over here, if it was in 1/8 from there to the end, 1 5/8, sorry, 1 5/8 from here to the next wire, that happens to be a corn slat. 1 5/8 is a corn slat. 1 1/8 is small grain. So I can get a closed slat, 1 5/8 as well. The only difference between this one here and the one that you have over here is the finger, the opening is wider. If it's closed in this area, just like this one right there, that's what we refer to as a closed slat. Okay? So that's basically the difference between the sieves. Okay, next thing I wanted to talk about is the back end of the top sieve. If we look down in here, we'll notice that this area is open back here. There's a piece missing here. This wire assembly actually goes right in there, and there's wire fingers over here covering this area. This one's been removed so that we could see where the rubber flap would fit. All new combines come equipped like this. They have a rubber flap bolted at the back end of the top sieve. So this rubber flap would fall down into here and basically close the area that the wind can come up through here to go through the wire. Because if the flap is underneath here, there's no wind can come through here. It has to come through the sieve. We added this at the factory. It used to be an option at one time. Okay, but there's some areas where people thought that we should have more air coming through the sieves instead of coming out through the fingers at the back. So we added this rubber flap at the factory. Most of you guys, with an 8010, 8120, 9120, 230 series, the first 240 series, do not have that rubber. It was only added at curtain. It was added the later part of the 240 series and then the 250 series. Now, sometimes in small grain, it can cause you some issues because sometimes it's nice to have air coming through the wires to catch some of those on-thrash heads and let them fall through here and go down into the returns. When I have the rubber over there, there's no air coming through here. So whatever doesn't get through the louvers gets blown over top of it, and it can cause you some grain loss, especially in wheat. So pay attention to it. If you cannot control your sieve loss behind, it might be that the curtain is causing you the issue in certain conditions. 9 times out of 10, the curtain can stay in there and be okay. But I've ran into conditions where I physically had to take it off. That was the only way to control the loss behind the combine. So, okay, hopefully that kind of helps explain a little bit about the cleaning system.